All right, Math 7, this is Unit 8, Mid-Unit Review. It's page 314, number 1 to 5. It's all the questions. Some of the questions I'm not going to count for marks, however, just because there's a lot of different ways it could be done and it's not as mathematical. So number 1A says draw a line segment CD of length 9 centimeters. Let's do it. All right. There we go. And we're going to label it CD. And we need to draw a point F, not on the line segment. So anywhere. I'm just going to pick here. That's F. Use a ruler and compass. I got a ruler. I've got my compass. To construct a line segment parallel to CD that passes through F. So there needs to be a line that goes through here. Okay, so we're going to use this and we're going to use that method that we learned. There's a lot of different I made a bunch of videos on how to do this earlier in the unit in 8.1. So I'm not going to explain the steps as I go because I've done that many times. We're just going to go through this quick and do it. Okay, so I just picked a point, I measured to F and put it there. Keep it the same measurement, and where it intersected over here, I'm going to push the pin down into it and draw another circle. Then I readjust the compass, I stick it on where that was at center and measure to F. And then I lift it up, put it back where the pin was for the first circle, arc it. And then I just draw a line straight through where those two circles line up and point F, and voila, there is my line that is parallel. As far as marks, I'm going to give you a mark for this outside circle, a mark that's the same size for the next one for this inner circle, and one for drawing the line through. So I'm going to mark it out of, and one for the line that was 9 centimeters long. So it's out of 5 for 1A. 1B says to draw a line segment CD again. So draw another 9 centimeter one. Use a different method to construct a line segment parallel to CD that passes through F. So we got to come up with another way that we're going to do this. Let's see. There's possibly another way we could do it. Oh, this was supposed to be 9 centimeters long. I need to adjust that. All right, and let's put a point F. CD is right here. Point F. There's a lot of different things we've learned. You know what? I'm going to try this. I'm going to try my best. I'm going to, I don't know, use this somehow. Use my protractor somehow. Maybe I'll use my ruler somehow. Let's see here. I'm going to measure, and it's 3 centimeters and 2 millimeters. So let's just go 3 centimeters, 2 millimeters over any other place perpendicular. With grid paper, this is a lot easier. But I'm going to measure that amount. And then I'm going to draw across from those measurements. Okay, and there's my 2 parallel lines. Now in some cases this could be good enough, in others it might not. So here part C says which method is more accurate. Also part B, I'm not giving a mark for that other than just one for doing it. There's lots of different ways. I don't know, maybe for chance your protractor just lined up perfectly and you could do it somehow. Maybe used a mirror somehow. There's a lot of different ways, but just for attempting some other way, right? Try it out. Now it says, see which method is more accurate. Well, part A is absolutely more accurate. What you're going to notice here, if I really zoom in on this line, is you're going to notice that it starts to become a little bit below the line. See right at the end, right here, it starts to get a little below that line, whereas over on the other side of it, for part B, right here, it's actually becoming a little above the line. So doing that measurement, it was a little bit off. It wasn't very good. Whereas this one up on the first one, it actually went straight across perfectly. This is a more precise measurement, and especially when you're doing big scale things, maybe constructing some building or a bridge or something, or some pipes, or I don't know, some big maybe thing that's made out of concrete. This type of measurement or calculation is far more important. Now, if you're just building some maybe garden box in your backyard for growing vegetables, doing something like this could be good enough, but part A is certainly the better one. So I'm going to say that's out of 1. All right, question 2 said, looking at this shape in your textbook, find all the sets of parallel lines. So ones that would be never intersecting, even if you extended those segments to be longer lines. Now we're gonna make sure we put things in alphabetical order. So looking here, I noticed that there's this line segment here, AC, has some other ones that are parallel to it below. So let's start with that one, AC. A is before C in the alphabet. And what other ones are parallel to it? Well, HE is. We're going to do EH for our answer. Why? Because that is alphabetical order. So that's one set of them. So that and that will be 2 marks. Next, we also have AH. It's parallel to this line way over here. These ones, if extended, would never cross each other. So AHCE. Oh, one quick note. Why is this one not this parallel to the first one? Well, you'll notice that this is slightly higher up than this one is, and eventually these two would cross, okay, if we extended them. So that's why it wasn't part of that first one. So it's AH and CE. Are there any others? Yeah, there are. What about this one down here, FL? It's also parallel. And this one here, GN is also. So there's actually 4 there that are all parallel to each other. So it's out of 4. And finally, there's one other one. It's maybe easier to see if we rotate. EN is parallel to FH. So that one's out of 2. So part A, if we add that up, it's out of 8 marks. Part B is now doing perpendicular. So these are the ones that would have 90-degree angles. All right, so first one I see here, we have AC right there, and CE. I also see AC and AH, which would be a 90-degree angle. So that's actually alphabetically the first one. So I see both of these, top right corner and top left corner. So those two are right angles. I also see AH as well as EH. Right here is a right angle. So AH and EH. I also see CE and EH. This is a right angle right here. So CE and EH. I also see that EH has this angle in here, which is FL. So EH and FL have a right angle. Now, we don't say this one is another one because it's still the same line segments, right? And also here, EH and GN. Okay, right here. Okay, so those are the 6 in this shape. This one's really close, but if we take our protractor and actually measure it, we're going to notice that it's actually only 87 degrees. Okay, so it's very close, but not quite. This one up here also very close, but it's about 91 degrees or 92 degrees here. So it's close, but it's not. Those two, this one here and this one here, if you wrote those, I'm not going to take a mark off right now. So anyways, each of these pairings is 1 mark, so it's out of 6. So question 2 in total is out of 14. All right, we need to draw for question 3 a line segment AB length 10 centimeters. So let's get this ruler. Let's draw a line 10 centimeters. Good. And we need to use a ruler and a compass. I've got both to draw the perpendicular bisector of AB. And if we remember that, perpendicular means not parallel, but up and down. They'd cross over with a 90-degree angle, and it needs to also be a bisector, which means it needs to be exactly in the middle. And so if this is AB, 10 centimeters long, all we need to do is put it at one end, put our arc through, making sure this amount is greater than half. Mine's cutting it close, but make sure it's greater than half, and then draw another arc. Okay, and where those cross over, we're going to draw with our ruler. We're going to connect these dots. I'm going to do it this side so I can see in the light a little better. There's my perpendicular bisector, and we'll just check. 90 degrees, absolutely. Okay, check. Is it right on that 5 centimeter line? Yeah, it's right on the 5 centimeters. So this is indeed a perpendicular bisector of AB. To give a mark for this, you get one for a 10 centimeter line. You get one for each arc. You also get one for then drawing and it actually being in the right spot. So it's going to be out of 4. Part B says we need to draw a line segment AB again. Use a different method to draw a perpendicular bisector. So come up with some other method. Okay, let's just draw this AB again, which is 10 centimeters long. I'm going to come up with a different way. Oop, just a little too long. Let's measure. That's a little too short. All right. One way you could do this is just measure in from the ends the same amount. So let's measure in 3 centimeters from the end on each end. Okay. Put a little dot, then use those dots as our center with our protractor, and we're going to draw the arc with our protractor, line up our center points. Okay. And where they cross over, we're going to draw with our ruler straight through that. Now, what's interesting is this method, I line up that bottom line perfectly. We're going to notice that the 90-degree angle is veering off to the right just ever so slightly. By the point it's up here, it's already off by almost a degree. So this it's not a perfect right angle, but it's pretty close. Any method you did here, whatever you came up with, is 1 mark, as long as it's somewhat close, within a degree or 2. C, how can you check that you have drawn each bisector correctly? Well, C, use a protractor. How do you figure that out? You use a protractor. Like this, okay? And the protractor, it measured whether it was actually a 90-degree angle, so if it's perpendicular. And then you also use a ruler, line up your 0 on the one end. Notice this, it's also a little bit off center, right? Why? Because there was an extra measurement we had to do each time, and maybe I didn't put the protractor exactly in the center of these dots or that sort of thing. So you're going to notice it's actually about 50.5 millimeters, and this way is actually a little bit less. It'd be 49.5 millimeters. So we're just going to see here that, you know what, using the compass is a better measurement tool. Question 4a says to draw a line that's 6 centimeters long, so I'm going to do that here. And it says it's the base of the triangle, so it's the very bottom there of the triangle. And it's labeled AB, 6 centimeters long. Okay, so that's 1 mark just for drawing a line. B says, construct the perpendicular bisector of AB. Label point C where the perpendicular bisector intersects AB. Mark point D on the perpendicular bisector. Join AD and DB. So there's some steps to follow. Let's do perpendicular bisector. Grab our compass. Put it at point B. Make sure it reaches past halfway. Draw the arc. Go to A with the same size. Do not adjust the size or you'll make a mistake. And we're going to spin it the other way. Grab our ruler. Connect the... Oop. There's our perpendicular bisector. So you'll get 1 mark for each of those arcs, so 2, and then 1 down there, so it's 3 so far. But after the perpendicular bisector, we need to mark point D on the perpendicular bisector. This is C, was another thing it said to do. And then D anywhere on this bisector. So I'm just going to pick here, I'm going to call this D. Okay? And then we need to join AD and DB. So AD and BD I'd like to call it because I like alphabetical order. Some people prefer left to right order and top to bottom order. Both are okay. They're just different conventions. So there we have that. So C was another mark. D was another mark. Connecting those was mark each, so that's 4. Each arc was a mark, that's 6, and the perpendicular bisector is 7, so it's out of 7 for part B. Part C says, what kind of triangle have you drawn? So let's just put C up here. What kind of triangle? Well, it is possible that it could be an equilateral, but only if this length is the same as this length is the same as this length. So if those 3 were the same. But this case, it's not. So this could be true, but it's actually an isosceles. Okay, that's the answer. Why? Because two sides are the same. From DB and DAD, those are the same length. And CD, this represents, what does CD represent? CD represents the height, right? Height of the triangle. So that length there, that height, and you multiply it by your base, you'd be able to then divide by 2 and get the area of this, right? So that's what it is. So 2 marks, it's the height of the triangle, and it's also isosceles for 2. Okay, if you did measure that this was the same length as this, so for example, maybe somewhere up here, and then this was 6 centimeters, then you could say it's equilateral. But if it's not, you can't say that. So this question was 1, 7 plus 2 is out of 10 marks for question 4. Let's do question 5. All right, we need to draw obtuse angle PQR and make it equal to 140 degrees. Use a ruler and compass to bisect PQR. So let's draw it first. I'm going to put a point right here, and I'm going to say that it is Q. Why? Because Q is the center of the angle. And then I'm going to make R over to the right side over here at my 0 degree mark. Okay, and P is going to be around 10, 20, all the way up to 90, 140 is right there, is that spot. And I'm going to connect the dots. Sorry, my head's getting in the way. I want to make sure I draw this properly. So we have that 140 degrees as described. Okay. Now we need to use a ruler and a compass to bisect it. Do you remember how to bisect? You take your compass and you draw a circle with the center being Q. And we just draw this circle. Oh, my one pencil's getting in the way. Draw the circle so that it crosses both of the segments that make up this angle. Okay. And then we take our compass, and those spots where it crossed, we are going to use that as the center of 2 other circles. And where these 2 circles cross is what will connect to Q. Now, the second and third circle, you can actually adjust this to make it bigger and it'll work. And I'm going to do that for one reason, and that's so that we can actually have a good measurement. But this circle, the second one, and this third one, these arcs need to be the same measurement with the compass, okay? The first one can be different than the other 2. It's okay. Okay, there we go. And now we connect it with our ruler. There's our bisector. So 1 mark for making the 140 degree angle, 1 mark for each of the arcs, so that'd bring us up to 4, and then a bisector would be 5 for part A. Part B says draw an acute angle CDE and use a different method to bisect. Okay, so we're going to start and we're going to do a 50 degree angle for this one. So CDE, let's put D right here. Let's put E over on this side. Let's connect those with a ruler. Let's set our protractor on there, line up the center, and make this line on E. And 50 is what we're drawing, so 50 is right there, 10, 20, 30, 40, 50. And then we can connect it. I don't use the edge of my protractor because it's usually, with mine, it usually puts a little bump in it, so it's not actually a straight edge. Some of them they are. So let's do this. That's C. We need to do a different method. Well, one way we could do it is trying to measure with a protractor and you know, go to 25 right there and then connect it. That's one way you could do it, but what I've noticed is it's really hard to perfectly line up that edge of our rulers and that sort of thing. But yeah, there we go. It's good. Okay, so that's equal to that. I forgot to mark this. That's equal to that. C, how can you check that you have drawn each bisector correctly? Use a protractor, right? That's one way. Another way you could do it is measure from the center a certain amount down each segment. So let's say we go here, which is 3 centimeters, and then go 3 centimeters here. And then that point where it crosses over, that will be the same length. So this here will be just under 4, it looks like. And then this here will be just under 4. Yeah, it's just under 4. So this line here is same length as that, and this one is same length as that. So in that sense, you can check if this was not the same angle, if it was a little bit over one way or the other, it would shrink or lengthen these, and it would no longer be the same amount. So for this one, drawing it was 1 mark, and then whatever you did, there's a lot of things. We're just going to say if you got one, some method, it's 1, and use a protractor would be our answer here. So this is out of 7. So our mid-unit review is 17 for this page. Six more for this page for question 3. So 17 plus 6 is 23. Plus 7 for question 1 was 30. Plus 14 is 44 is what the mid-unit review is out of.